I'm Paige Moreland. I'm the Executive Director of Legacy Partners in Environmental Education. On behalf of the staff and our board of directors, I'd like to welcome you all this afternoon and thank you so much for joining our first Earth Month webinar featuring Dr. David Cline. For those of you who aren't familiar with Legacy, we are a nonprofit organization that was founded in 1992. We serve citizens throughout the state of Alabama. We are funded through the sale of the Protect Our Environment license tag, which you can see on your screen. And if you look down at the bottom of the screen, you might want to jot down our website. Through that website, you can find out about things like teacher trainings, which we normally hold in person every year, but COVID has changed that a little bit. We just got through with a week-long Mountains to the Gulf, which was fantastic. And we're working on some more virtual programs and hopefully some more in-person workshops later on this summer. Also there, you can keep up with that, but you can also see all of the educational materials that we offer. We have a series of 12 posters that feature different subjects in Alabama. We've got birds, butterflies, reptiles, spiders, plants. Anyway, there are 12 different ones that you can order from our website, as well as some energy conservation guides, water conservation guides, and educational wheels. We don't charge for the materials, but we do charge just to cover the cost of the mailing and the poster tubes. We also offer a grants program that we just finished for this year, but if it's something you might be interested in for 2022, you'll want to keep an eye on our website this fall once those dates are announced. We also have another webinar next Thursday, a week from today, that will feature reptiles with Jimmy and Sierra Stiles. So I hope that you would be interested and take a look and sign up for that as well. You can also join our email list through our website if you're interested in getting communications about what we have to offer in the future. So with that, I'd like to say welcome again, and I'll just turn it over to Dr. Cline.
All right, very good. Welcome everybody, and thank you for coming. I am going to talk today a little bit about aquaponics for the classroom. We'll talk a little bit about what aquaponics is and then how it can be applied in the classroom, and then some resources that I have to share. But I'm going to stop my video so it doesn't interfere with the recording, but I will still be here and we will go ahead and get started. So let's start with what is aquaponics. Aquaponics is a combination of aquaculture, which is growing aquatic plants and animals in a controlled or semi-controlled environment, and hydroponics, which is growing plants usually in an inert media without soil. So the two of them together is aquaponics, and it can look like almost anything and be present at any scale, from a tabletop operation all the way up to a commercial scale operation. So it's not really important what the system looks like, but that it meets the needs of the plants and the fish. And some people may think that aquaponics is new, but it's actually been around for a long, long time, going way back to the Chinese, who actually grew carp along with their rice crops. And believe it or not, the first manual for producing carp in aquaculture was written in 450 BC, and I think this was actually 454 BC, by Fan Li. The Aztecs also used aquaponics. When they were moving through a valley, they came upon a lake that was surrounded by reeds. They needed a place to grow their crops, so there was no land available. So what they did is they took those reeds and wove them together and floated them in the lake. And then they pulled up soil from the bottom, put them on the rafts, and then planted their crops on the rafts. And those are called chinampas, and remnants of those can still be seen today. But aquaponics has made a resurgence in modern years. And most of the current information that we have about aquaponics comes from research that was done at the University of the Virgin Islands by one of our very own Auburn University Fish Mafia graduates, Dr. Jim Ricosi, who started working back in the late 80s down in the Virgin Islands in St. Croix. And almost all of the moderate to large scale systems that you'll see are based on his original design or some variation of it. That includes, and hopefully you can see the cursor, some fish tanks, and then there are a couple of filters or settling chambers, degassing. The water goes out to the hydroponic tanks where the plants would be and comes back. These folks in the picture over here are some of Dr. Ricosi's students and coworkers. The person in the middle there is Jason Danaher, who actually got his PhD in aquaponics here at Auburn recently, and Charlie Schultz on the right and Don Bailey on the left. But some of the benefits of aquaponics, one of the reasons why it's important and there's a lot of interest in it, is because it can use 1/10 of the water that's typically required to grow crops in the field. So it's very good at conserving water. It also is very good at production. In fact, you can produce up to 30 times greater, 30 times more vegetables and crops using aquaponics than you can do with traditional agriculture. So it saves water. You can grow a lot more per unit area. You can put it in an urban environment if you wanted to, because most of the time it's in a greenhouse. So it could be close to the market and it has several other advantages. But let's talk about the components and what goes on. So the fish are obviously an integral component and provide the engine for the system. But there are several things fish need to survive. And hopefully you can guess what at least a couple of those are. First one typically is water. And these are the order that I get them in when I talk about this to folks. They usually say water, food, we usually get to oxygen, and then there's a big pause. And some people say sunlight, some people say algae, but really what they need is some mechanism to get rid of waste. Because if you think about it, you know, as humans, we use the restroom and the waste magically disappears. But if you're a fish, that waste goes right back into their environment. So they need some mechanism to get rid of waste. And it just so happens that plants also need approximately 4 things in general categories to survive, including light, air, or CO2 to photosynthesize. They also need water, and they need a source of nutrients. So this works out really well for this system in which we can feed the fish and recapture the extra nutrients and utilize them to grow plants. The primary waste product from fish is ammonia and carbon dioxide. So the carbon dioxide that's excreted from the fish through the gills typically comes out into the environment and can actually be the CO2 for terrestrial plants. And then we are depending on bacteria in the water, or in our case, on some surface of some media, for that bacteria to break down the ammonia first into nitrites, which are also toxic to fish, and then into nitrates, which are relatively non-toxic to fish. And then those nitrates can be used to fertilize plants. There's 3 basic forms of aquaponics. These are the major forms, and then there's some offshoots of them. But nutrient film technique, or NFT, ebb and flow, and then floating rafts. And we'll take a closer look at those. NFT is basically a thin layer of water and nutrients that flows along the bottom of a channel or a container. It usually runs consistently. This is typically used in hydroponics as well. There's a nutrient solution. In this case, it's fish and fish waste that gets pumped into a gutter system, much like these. The water and nutrients runs along the bottom of the tray and back down into the fish production system. For an ebb and flow system, it does just what it says. It ebbs and flows. So the water level in the plant container rises and falls. And this can be done using a pump and a timer. It can also be done using what's called a bell siphon. And we're not going to get into that too much today. I'll show you a picture of what one looks like, but that's a very interesting physics experiment and a great way to illustrate some academic physics principles using a bell siphon. This is an example of a medium scale ebb and flow system. What we've got is we've got 2 barrels in the ground. These did not have fish in them. We just took fish water from a larger fish tank, put it into these barrels, and then the water was constantly pumped to the end of the ebb and flow box. This box contains some expanded clay. It looked like giant kitty litter. The water flows through the plants, fills up the box, and eventually overflows via this bell siphon and goes back down into the barrels. So the water level rises and falls. But this is a top-down view of what that bell siphon looks like. It's a standpipe inside the container. This one happens to have a flared lip, and then there's an outer, slightly larger PVC pipe with a cap that goes over the top of that. So when the water level rises, eventually it starts overflowing the standpipe. If the water gets moving fast enough, it will suck the air out from under the cap, which starts the siphon. The water flows out very quickly and drains the tank. And hopefully, when you're in your ebb and flow system, you're going to have about 3 distinct zones. The top zone is the dry zone. That's zone number 1. And hopefully, you don't ever want the water to get above the top of the media in your system, because anywhere where there's water and sunlight, chances are something's going to grow. And usually in this case, it's algae, and you don't really want algae growing on the top of your media. And then that root zone, that's going to be the area where the water ebbs and flows. So that's where the plant roots are going to be when the water level is down. Those roots are exposed to the air and the oxygen in the air. And when it comes back up, they're exposed to the water. And then that small layer down there at the bottom can be used for solids collection. Ideally, you don't really want to have much in the way of solids in your media, but you can add some worms and they help break down some of those solids. And we'll talk a little bit more about how to get rid of some of those solids later on. But in terms of the media for your ebb and flow system, you want something that's inert, so it doesn't add any nutrients or ingredients, but you also don't want it to, this is often used in hydroponics, this perlite for drip systems or Dutch buckets, but it's like styrofoam. So if you put that into a box and then flooded it with water, it would just float over the top. And then these other organic things tend to break down and sometimes change the pH or other water chemistry parameters that you might not want. This is a nice example of an ebb and flow system that is safe. It's called a constant height in the fish tank pump in the sump. And what's going on is down here at the bottom right, there is a sump with water in it. The fish tank is at the top. So we've got the water being pumped from the sump into the fish tank. When the water level in the fish tank rises to near the top, it overflows into the plant tank. Underneath this white cap is a bell siphon. Once the water level rises, it flows back into the tank, into the sump, and then gets pumped back into the fish tank. The nice thing about this system is that if something were to happen, like the power goes off or your pump gets clogged, nothing will change. The water level in the fish tank won't change, the water level in the plant tank won't change, and it won't drain out or overflow the sump. So that's a very good, safe example of an ebb and flow system. Probably the most common type of aquaponics, as well as hydroponics, is raft culture. And this is basically a styrofoam raft or a plastic raft with holes punched in it that you place new plants into so that the roots can hang down and be in contact with the water. It is often used for leafy greens, particularly things like lettuce. Basil also does really well in these systems. And for a starter system, like at your school, if you were going to do this or in an educational program, I would recommend things like lettuce and basil just because they're relatively hardy and fairly easy to grow. Another type of offshoot of the main forms of aquaponics is these Dutch buckets. And what we're looking at is these are containers. I've seen them made out of 5-gallon buckets, but these are fancy Dutch buckets that have a little lip in the bottom where they can sit over the top of a PVC pipe. Each of the buckets has a drip emitter, so it delivers the water directly to near the stem of the plant, flows down through the media. Usually in these cases, it's perlite. And then if it's not absorbed by the plant or used by the plant, it overflows into this PVC pipe and can be collected and either returned to the fish tank, which is not common, or it can be used, the water can be used for growing plants, say in raised beds. So all the water is being used. As I mentioned, doesn't matter what these systems look like as long as you're meeting the needs of the plants and the fish. And they come in a variety of sizes. This gentleman called me years ago and told me that he wanted to take his old pontoon boat and turn it into an aquaponics system. And his plan was to put the fish in one of the pontoons and the plants in the other. I was not a fan to begin with. I could see lots of problems, but he did end up being successful with it. And I talked him into behind this pontoon is a probably 8-foot by 20-foot long pond that's a lined hole in the ground where he's got some tilapia and koi. And these have been very effective ebb and flow gravel containers. You can see even in the corner here, he's even got bananas growing. He's grown coffee, peppers, all kinds of medicinal herbs. He even has had luck with reproducing the tilapia, so creating his own fingerlings for this system. So it's not to say it can't be done. You just have to be creative. So the next question is, why are we interested in aquaponics for the classroom? We recently conducted and turned out to be an international survey of people interested and engaged in aquaponics to try and get sort of a snapshot of the industry. And this included about 100 educators from K-12 to informal educators to university and extension folks. And they indicated that they agreed with this statement that my students are academically engaged when I teach using aquaponics. Got a very good response. They also thought that aquaponics was very useful for teaching a variety of academic subjects. Of course, agriculture is one of the top ones, but if you look just down the list, ecology and biology are right up there near the top in the very useful to extremely useful categories. They also teach, in addition to these academic skills, they also teach a number of life skills, including creative problem solving. And anybody that's done any aquaponics or even aquaculture knows that eventually you're going to have a problem or the fish will die or the plants will die, and you've got to figure out how to solve that problem. Working with live animals and plants also helps the students develop a sense of responsibility in taking care of live creatures. And oftentimes they have to get together to learn things and figure out solutions. But we've heard anecdotally from teachers that these are cases often that the students who may or not be the most academically inclined students develop into leader roles because they can see the practical application of those academic subjects in a practical real world form. So let's look at some of the different ways that you can use aquaponics in the classroom. Of course, we've got it makes a very good example of food chains, food pyramids, symbiotic relationships, having the different types of organisms present in the same environment. Lots of biogeochemical cycles going on. We've got the water cycle. Particularly important to this one in aquaponics is the nitrogen cycle and what happens to that ammonia and how it's broken down into nitrite and nitrate. Students encounter most of the time photosynthesis several times during their academic career at different levels. If you have a body of water and some sunlight, as I mentioned, you're going to get some algae. Those algae during the day produce oxygen. This is extremely important for us in aquaculture in ponds. We monitor the oxygen levels as they go up during the day. Of course, as soon as the sun goes down, those oxygen levels start to drop as the algae and bacteria start to respire and use up that oxygen. So what you end up with is one of these humps that day after day turns into a wave and can become critical should there not be enough oxygen for the fish, because you can imagine if the oxygen level gets down to 0, the fish do not do well. There's a tremendous amount of math involved in the maintenance and creation of these systems. Certainly, anytime you're dealing with water, you can calculate volume, and area is very important. It's actually the surface area of the media in the biofilter and the plant tank that determines how much feed the system can absorb and how many fish you can have in the system, or how much weight of fish you can have in the system. Based on the fish's size, the students can calculate feeding rates, feed conversion ratios. Occasionally, they'll need to do a water treatment to change the pH, and they'll need to know the volume as well as things like parts per million measurements, how to work with those. And then, of course, there are sampling, graphing, and conversion opportunities. And if we go to the plant side of things, got all kinds of things that they can study, including the physiology and morphology of the plants, talk about how respiration works, transpiration works, photosynthesis, looking at the pests and diseases of plants. And if you look at this poor little, I'm pretty sure this is a tomato plant here in the middle, that it's obviously got some problem and lacking nutrients, which can open up a whole new category for study. And then on the fish sides of things, chances are most aquaponics beginners start with tilapia, and there's a reason for that. It's very hardy with everything except temperature. It is a tropical fish that will need to be kept warm, but you can use tilapia as an example of genetic manipulation. And this guy on the right-hand side of the screen, this over here, this is a super male tilapia. And just if you, very interesting discussion, but we can take male fish when they're babies, treat them with a little bit of estrogen and turn them into functional male or females. And while they still have the XY chromosomes, they're functionally female. If you cross those fish, you end up with XY and XY females and XY males. You cross those guys, you end up with some XX, some XY, and then these YY fish. And these are the super males. So now you can take those super males, which are YY, cross them with any old female or the XX female, and end up with essentially 100% male fish. And that's important because male tilapia grow faster. They don't expend energy on producing and protecting, incubating the eggs. So that they are commonly used now in aquaculture and in aquaponics just to avoid the reproduction of these guys, because they think that this fish is actually the fish from the loaves and fishes story in the Bible, where they took just a few fish and turned them into a whole bunch of fish, because they are very fecund and can reproduce almost once a month. You can teach social studies. Of course, you can talk about where these fish and plants originated, history, sociology, psychology. Aquaculture and agriculture is a global industry, so you can talk about different places, different languages, lots of interesting history surrounding aquaculture. In fact, there are inscriptions of tilapia inside the Egyptian pyramids in some of the tombs. And you can see in this picture, these guys actually were netting and had tilapia in an enclosed environment, indicating that they were, at least in some form, farming these guys. You can talk about the ecology. Anytime you're putting nutrients into the water, there's going to be some environmental changes. So there are certainly no shortage of opportunities to look at different types of aquaculture and aquaponics and the benefits of aquaponics in treating that water. And in general, most of the time we're doing aquaponics and aquaculture as a source of food, which is very important globally. In fact, I think up to 50% of the world population uses fish and seafood as its primary source of protein. And then let's not forget that aquaponics and aquaculture are potentially a business. So you have to look at things economically, figure out the costs and returns in doing aquaponics, figure out how much it costs to build the system, and then eventually, hopefully you'll have some products to market and can expose the students to opportunities for marketing. And there were these folks down here in the bottom are some Auburn High School students who did a project and won a prize through their FBLA program using aquaculture as an example. Hopefully, if you are creating food and fish, they can be used to teach consumer science and food safety and food preparation, how to safely handle these guys so that folks don't get sick. Different culinary preparations. These are, again, our students from the Auburn High School in the culinary program, hopefully using some of these products that you can use in your cafeteria or even to make a fish fry and some salad for your administrators if you happen to be at a school. But great care needs to be taken anytime you're working with a product like these vegetables that could potentially come in contact with bacteria, although that hasn't been a problem in aquaponics. Need to be extremely careful when you're eating the raw product and making sure that they're properly cared for. You can turn these things into fashion. These fish skins are now being used for different types of leather. These down here in the corner are tilapia skins. This is a sneaker made out of tilapia skin, as I'm pretty sure this shoe is. You can even make outerwear, bathing suits, etc. This is a sturgeon skin that was turned into a belt. And these boots are actually made out of cod skins. So you can take this as far as you want. In fact, now tilapia skins are even being used as a replacement bandage for burn victims because it keeps they can be sterile, keeps the wounds moist, and helps them heal. You can talk about music. Fish make sounds. I don't know about the plants making sounds, but the fish definitely make sounds. In fact, there were some creative people that turned animal sounds into a whole album, one of which includes fish sample noises. We've got a researcher at Auburn University that studies the sound that fish and shrimp make. Lots of literature opportunities, no shortage. This one, if you're interested in water, and particularly water and the environment, The Big Thirst, I highly recommend. Lots of great facts and figures about water and the environment and its importance to us. Some of these other fiction novels, Clive Cussler is one of my favorites. And this book is about a killer mutant aquaculture fish that they were going to release in the ocean that was going to eat up all the other fish so that folks would have to buy fish from them. And they do happen to mention a certain university in Alabama who is doing genetic work, but we'll leave that for another story. And then there's all kinds of art, and I'll just give you a quick tour. When I was putting this presentation together originally, I just ran around my house and took pictures of the things in my house. You can use your fish and plants as storytelling mechanisms. Let the students develop stories, look at their life histories. There's no shortage of art using fish as a subject matter, as for plants for that matter. So there's No shortage. This is a Gyotaku print. This is commonly used in ichthyology classes to teach fish morphology. It's basically you rub ink on the outside of the fish, or it can even be paint, and then press it onto this. In this case, it was rice paper, and hopefully it shows the different characteristics of the fish. I'm a big koi guy, so I had to show you my koi prints that I'm proud of. But let's talk about some of the practical applications in your classroom, how you could build these things, and give you some resources to get started. So we have been teaching oh my goodness, pardon me, an Aquaponics 101 workshop for teachers for over 20 years now, and have trained over 500 teachers. And currently we are building these small scale systems that teachers get to take home to their classrooms, that they can use to teach the same principles that we've been talking about. And in this particular system, we've got a small aquarium. As I mentioned, anywhere you've got water and sunlight, you're bound to have algae. So this was what happened when we had this system outdoors, is we did grow a little algae. But that water from the fish tank is pumped up into this filter. This is a mechanical filter. It goes down through a series of foam pads into the bucket, and then once it overflows, it flows out into the plant tank, where it goes down into the media, which in this case we have clay balls. The water level rises, the bacteria growing on those balls breaks down the ammonia into nitrite and nitrate. The plants take up the nitrate, and then it flows via the bell siphon back into the fish tank, and the whole cycle starts over. We just recently created a publication on how to build one of these that includes specific instructions with lots of photographs. Then it's available on the Alabama Cooperative Extension System website. If you go to that aces.edu website and type aquaponics in the search bar up here, hopefully it's one of the things that will come up, as will some videos related to aquaponics and some of our projects. So this is the smallest scale that we've worked with. We've also worked with what we call IBC aquaponics, and IBC stands for Intermediate Bulk Container. And you've probably seen one, even if you didn't know what it was called. It's one of these white plastic containers inside a metal cage. And we've created this fancy facade here to kind of cover up the cage, which is not all that attractive, but it's one of the most commonly used aquaculture system for beginners, or aquaponic systems for beginners, because you can just slice off the top, flip it upside down, put in our case, we use pea gravel. And these are great for growing things like tomatoes, peppers. We've got some Swiss chard in there. But you can see this system has been pretty productive. In fact, this year we've harvested over 1,500 tomatoes off of this single IBC setup. It's got some tilapia down in the bottom. We're feeding it about 60 to 70 grams of feed a day. And those nutrients are obviously being put to good use. There is, on the ACES YouTube channel, we've created a series of videos, and hopefully you can see this on the step-by-step formula for building one of these IBC aquaponic systems. If you'd like to give it a try, there's a series of 5 or 6 videos, as well as a couple of videos related to the tabletop system. There's a video on how to put that together step by step. That one is available on the ACES website, but in terms of other resources, we've also got this Aquaculture Education and More YouTube channel that I've created with the help of others. That features about 60 videos, I think we're up to now, including a couple related to these small scale systems. This is a brief description of how that system works and how to put it together. In terms of other resources, lots of new resources available The one on the right is very good. It was designed for small scale aquaponic production around the world. So generally low tech, and you can use, these are again, those IBC containers that we were talking about. They're very common. Kentucky State University just created in the last couple months, they just released this aquaponics production manual that talks about the theory and the mechanics behind aquaponics. And over in Europe, they've even released this entire aquaponics curriculum for teaching aquaponics at a variety of levels. It includes resources for students as well as the educators. There's still, you still have to fill in the blanks, but it provides the structure to do that. And there are a couple of other aquaponics curriculums out there that show you how to integrate aquaponics into your classes. So what can we do for you as educators and aquaculture specialists? I don't claim to be an education specialist, but what I do know is how aquaculture and aquaponics relates to sciences and the subjects taught in schools. So we can provide you with the information, and then you can take that information and apply it to your particular situation and adapt it for the appropriate level that you're teaching. And we can give you some hands-on examples of activities that work and potentially even some lesson plans. And now I'm going to subject you to a shameless plug for our Aquaponics 101 workshop. This video was created 2 years ago, I think, with the help of our extension folks, but I want to let you listen to what these people say. And these are teachers. Whoop, up, up, up.
This workshop compares to other professional workshops that I have attended in that it is completely hands-on, very applicable to what I will be teaching or what I aspire to teach.
The information from this workshop is going to greatly benefit my students, and this material we're covering really gives me a better tool set in order to explain those concepts, and also gives the kids an opportunity to do something hands-on that they might not otherwise be able to do.
This is a great cross-curricular tool between mechanics. I can have my shop classes build things. My greenhouse classes obviously would be the ones in charge of the aquaponics system, along with our biology and chemistry departments, and even breaking it down to our math department in our elementary schools, getting them to come out and write stories about the fish or count different fish and kind of learn about where they came from and that type of things, or what type of fish would benefit our systems the best. And also it gets our students involved with our FFA program before they even get into high school.
So hopefully that worked out well and you were able to hear it. But this is the real reason why we do to help teachers understand aquaculture and aquaponics. It's when you see these aha moments like this, it makes it all worthwhile for us teaching those workshops. And at this point, I think that's all I had to say about our presentation today. Please, if you've got questions, type them into the chat box, or we'll open it back up and folks can turn on their microphones. Please check out that YouTube channel, and you can find that typing in Aquaculture Education and More, or just David Cline, and that'll get you there. And I've also posted some nice pictures and things on the Twitter and YouTube channel. And don't forget to visit the Legacy website up here. It's just been recently updated and looking pretty slick these days. And we also, don't forget, we've got that other webinar coming up next week, and with Sierra Stiles, who's going to talk about reptiles. So please join us again for that. And with that, I think we've come to the end.